about radians and degrees. They're the two ways that we can measure angles when we're talking about angle measurement. And basically everything in trig has to do with something called the unit circle, which is what I handed out to you guys at the front of your notes. But where I want to start today is actually the unit circle. So this is on your notes in 4.2, but I thought I'd make a bigger one here. Okay, so this is called the unit circle. So basically a unit circle, it's kind of like, you know how we have y equals x is the standard equation for a line and y equals x squared is the standard equation for a quadratic. Well, this is a unit circle. So obviously it's a circle. Its center is at the origin and the radius is 1. So that's where we get the idea of 1 unit, a unit circle, right? And the equation is x squared plus y squared equals 1. Just a quick review from Algebra 2. This number here actually tells you what your radius squared is. So if I put in 25, then I should have a circle with a radius of 5. So just to kind of review that. All right, but we're talking about the unit circle, so we just want a radius of 1. Nice and simple. We're not even going to make any fancy requests. We're just going to go with that. Okay. So if this is our unit circle, hopefully this will work for me. I had to restart because my other class, Paint, was acting up on me. It was being mischievous. Oh, yay. Sort of. No, it's still doing that. All right, Paint. Okay. Well, I'll keep switching over to make sure that I got the chat so I can see what you guys are talking about. Okay, so if this is a unit circle, we're going to talk about the definition of trigonometric functions as it pertains to the unit circle. Okay, so we're going to say that we have some real number, and so this is on your sheet. This is, if you have your notes, we're basically talking about not all that stuff yet. We're right here. We're talking about this blue box, the definition of trigonometric functions. Okay, so we have let t be a real number and x and y be the point on the unit circle corresponding to t. And then we're going to define what sine, cosine, tangent, and cosecant, secant, and cotangent are. All right, so first of all, before we even get started on any of that, who can tell me what sine, cosine, tangent are the ratios? What ratio does the sine represent? The sine of an angle represent? So if you wanted to find, I feel like I'm not asking this question right. If you had, here we go. If you had an angle, theta, right? And you wanted to find the sine of theta, what are you going to use? How are you going to find the ratio of that? So if this is the hypotenuse, right, of a right triangle, and this is the opposite side, and this is the adjacent side, the sine of theta is the opposite side over the, who remembers? Hypotenuse. So this is the acronym SOHCAHTOA. SOHCAHTOA helps you remember sine, cosine, sine, and tangent. So this is kind of a review back to that, okay? So sine is the opposite of the hypotenuse, right? What is the cosine of theta? The cosine of theta is the adjacent over the hypotenuse. And the tangent of theta is the opposite over the adjacent. Okay, remember all of these have to do with a right triangle. So this is from back a little bit in geometry. It was in geometry for a little bit that we talked about the sine, cosine, and tangent and what that means. Make my right angle better. Is that vaguely familiar in the back of everyone's minds?
Yeah.
All right, cool. Kenzie, you got Mackenzie and Greta, you good?
Yep.
Cool. All right, cool. Greta's good too. All right, so we got that. Now we're going to apply that to this guy, the unit circle. Okay, so if I were here at the origin and I go out some distance, right, to some point right here, this point is x, y, some x and y, right? And this is my angle, my theta. Okay, what is the distance of my blue line here? That's 1, right? That's 1. And the distance from here to here is x. And the distance from here to here is y on any point of my unit circle, right? So if I asked you, yikes. Okay, thanks for letting me know, Facebook. All right, if I asked you what the sine of theta is, okay, the sine of theta is the opposite over the hypotenuse. My opposite side is y, and what's my hypotenuse? It's 1, right? So the sine, or y equals the sine of theta on a unit circle. You see that? Because the unit circle has a radius of 1, that means my hypotenuse is always 1, which means that the coordinate for y equals basically the sine of theta. Okay? Does that make sense so far? Kinda?
Sort of.
Yeah.
Sort of, yeah. Okay, so then let me do another one. If I wanted to know, I'm just talking about this unit circle here. This is my angle theta, right? If I wanted to know what the cosine of theta is, right? The cosine is my adjacent side over my hypotenuse. My adjacent side is x, and the hypotenuse, again, is 1. Right? And so my x coordinate equals the cosine of theta. Okay? And then tangent, our good friend tangent, right here in the middle. Tangent of theta is not quite as pretty, right? But tangent of theta is my opposite over my adjacent. So my opposite side is y, and my adjacent side is x. Okay? So these are kind of the general formula, and you're going to be using this a lot, what that kind of means. So those are the 3 basic trigonometric functions. Okay? Then, but wait, there's more. Then, we'll go Christmas colors, we'll go opposite. So each of these sine, cosine, and tangent function has a reciprocal function, of course, right? reciprocal function. This one we didn't talk about as much. So these are your like 3 basic trig functions, sine, cosine, and tangent. Each of those has a reciprocal. Okay? So the reciprocal of sine is something called the cosecant. The CSC stands for cosecant. Starting to spell it right. Okay. C-O-S-E-C-A-N-T. Okay. So the cosecant of theta is basically 1 over the sine. All right. And so we said down here that the sine of theta is y, so the cosecant is 1 over y because it's the reciprocal. Okay. The cosine also has a reciprocal. The reciprocal of the cosine is called the secant. Okay. And that is SEC. So the secant of theta is 1 over x because the cosine of theta is x. The secant of theta is 1 over x. So reciprocal. And of course, tangent has a reciprocal. And the tangent of theta has a reciprocal called the cotangent. Okay. So the cotangent is the COT. The cotangent of some theta is going to be, instead of y over x, it's going to be x over y. All right. So that's just like a bunch of information. And then on your notes, there's actually a unit circle that has been divided out. Let me zoom in a little bit here. This is a unit circle that has been divided out into 8 equal arcs. And then this is a unit circle that has been divided out into 12 equal arcs. The unit circle that I gave you on the front of your notes actually is a combination of both of those. So basically the unit circle that I have on the front, that big one that says unit circle that I'm going to make a better copy for you of, that represents some of the most common pieces of a unit circle that we're going to use. So this actually tells you the position of x and y at different values on your unit circle. Hopefully I haven't completely lost you. I know this is very exciting. All right, so kind of what that means, well, not kind of what it means. What that means, if I bring this all together, let me see if I can copy this little unit circle guy. Yeah, I can. No, I just want to copy it. Let's go back here. So what this means is if I looked at a unit circle like this, and that's not the best view, but, and I just know from math, right? This line here, this is, if I go all the way up here, this is 90 degrees. So I know that this is 45 degrees just from general knowledge about circles, right? You guys are okay? This is 45 degrees to this angle right here. Is that all right?
Yeah.
Yep. Okay. So what that practically means is that if I asked you, okay, Greta's good with that. That's totally rad. I like it, Greta. I agree. It's totally rad. All right. So what that means is if I asked you what the sine, sorry, I'm typing with my mouse. Let me say, if I asked you what the sine of 45 degrees is, okay, you could obviously plug it in your calculator, right? But I also know that this is a unit circle. It's a unit circle because I have 1, 1 and negative 1, 1, right? The sine of 45 degrees, the sine of 45 degrees is my y coordinate. So I can look here and my y coordinate is right here, right? So the sine of 45 degrees is the square root of 2 over 2. So I can find that without having to like go to Desmos, plug it in, figure it out, do whatever you need to do, right? If I wanted to find the cosine of 45 degrees, the cosine of 45 degrees is my x coordinate, right? Which also happens to be the square root of 2 over 2. It's not always the same, it's just because I picked this one. Okay, and then if I wanted to find the tangent of 45 degrees, that is the same as y over x, which is the square root of 2 over 2 divided by the square root of 2 over 2, which is 1. So just to kind of prove it full circle, if you're like me, I always like to go to my calculator and make sure that it actually worked. The first thing you're going to do is you're going to want to make sure that whenever either calculator you use, TI or Desmos, it's always going to have a radian and a degree function. Since I was talking about 45 degrees, I need to switch it to degrees, right? So if I wanted to find the sine of 45 degrees, that's 0.707 whatever, which is, we said was the square root of 2 divided by 2. Blah. Figured out what it was without a calculator, right? By looking at a unit circle. And the same if you do the, cosine of 45 degrees. And if you do the tangent of 45 degrees, we get 1. So we were able to find the sine, cosine, and tangent of 45 degrees by just using a unit circle versus using some kind of chart. And wow, when I switch back, that looks crazy, all right? So this is this is one purpose of one of the big purposes of the unit circle, right? If I extend that a little bit further, scroll in a little more. It's actually kind of cool that you can do that. All right, copy to clipboard. Okay. If I would extend that, this circle has been divided into 12 equal parts, right? Oh, when I zoomed out, it didn't stay square. 12 equal parts, right? So that means that all the way up to here is 90 degrees. If I divide 90 into 3 sections, that means that this is 30 degrees to this lower guy, right? And then to here this is 60 degrees, and so on. So then it works. If I wanted to find the sine of 30 degrees, the sine is the y component. So the sine of 30 degrees is 1/2. And if I want to find the cosine of 30 degrees, that's the x component. So the cosine of 30 degrees is the square root of 3 over 2. Okay. Does that make sense? Sort of.
Yeah.
Cool. Kenzie?
Yep.
Greta? Sort of. Yeah. Now you just need to like figure it out, right? Okay. I'm trying to decide. There's a second part of your notes. I'm trying to decide if I want to. Da, 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 da. Yeah, let's go ahead and talk about. Let's go ahead and talk about that. So the second part of your notes. No, actually, let's come back to that. Basically, if I don't get to this at the end, the second part of your notes talks about the period and the domain of a sine and cosine, which is kind of interesting. So the big idea is that if you think about a circle, sorry, right? If you think about a circle, that's 360 degrees or 2 pi radians, right? But what if I wanted you to find the cosine of 390 degrees, right? So 360 degrees is one rotation. 390 degrees would actually be one rotation plus 30 degrees more. So basically the idea is that when you have a sine or cosine of a number, if it's bigger than 360 degrees, or it's less than 0 degrees, like say I wanted you to find the sine of a negative 30, right? You can think about where that is on the unit circle based off its position. And then that actually, you kind of get this curve where you're kind of rolling out the unit circle. And that's why the sine function, when you graph a sine function, looks like, you ever graphed a sine function before? And that's not going to work because I'm on radians. Let me try it back there. There we go. All right. So the reason that the sine function actually kind of repeats itself over and over again is because this one period of your wave, right, is basically 2 pi rotations around your circle. So you can see Desmos is actually pretty smart. And it labeled this is the first 90 degrees basically of your unit circle, the first 180 degrees, 270, and 360 degrees. So I'll explain that better when we get there, but it's actually kind of cool that this unit circle idea plays into why a sine curve and a cosine curve have this repeating kind of wave to it. Aren't you excited? Can't wait till we get to that point, right? Okay, so let's try some examples. Actually, and give me one quick second. I'm going to get a quick drink of water. So get your pencils ready. I'll be right back. Okay, who's excited? Woohoo! I can hear you cheering through my computer. Okay, here we go. So in 1 through 4, determine the exact values of the 6 trig functions of angle theta. So this is actually pretty easy exercise, except that we just need to remember the definitions for all 3. Sorry, I got a drink of water. I thought it helped. Hold on a second. Okay, hopefully that helped. Sorry about that. All right, for example, number 2. My nose is all like stuffed up. Number 2, we have that theta makes an angle with a line that ends at 12/13 and 5/13. Okay, so what we want to be able to do in these kinds of problems is, number 2, we want to be able to list all 6 trigonometric functions and tell what they are. So we have the sine of theta, we have the cosine of theta, we have the tangent of theta, and then we have the cosecant of theta, the secant of theta, and the cotangent of theta. Okay, so the sine of theta, if you have your notes back or you want to look back, the sine of theta is always if you have an x and a y coordinate, the sine of theta is always the y coordinate. So the sine of theta is 5/13. Okay, the cosine of theta is always the x coordinate. So it's 12/13. Right? The tangent of theta is always y over x. So in this case, it would be 5/13 over 12/13, which is 5/12. Okay. The cosecant is the reciprocal of the sine. So what is the reciprocal of 5/13? It's 13/5. Remember reciprocal, you just flip the numbers, right? The secant is the reciprocal of the cosine, so that would be 13/12. And the cotangent is the reciprocal of the tangent, so that would be 12/5. Voila, right? Looks intimidating, not too bad. Greta, I just saw that you were super pumped. I'm very excited that you're super pumped. It is very exciting, right? Okay, so now let's move on, right? Let's look at numbers 5 through 16. So 5 through 16 says, you're cracking me up, Greta. Find the point xy on the unit circle that corresponds to the real number t. Okay, so this is a little bit funny because I didn't use I instead of t, I used theta. So in here, when you see their t, that basically means theta. Okay, so for example, they want to know what point on the unit circle is where theta equals pi over 3. Okay, so this is where, again, that first page of your notes is going to be your friend. Eventually, I think my last pre-calculus class ended up memorizing it just because it was just easier. So you probably, by the end of this, will have most of it memorized. I just want a unit circle to look at. Okay, so the problem was, and I'll print this out better for you guys too, but the problem was, tell me what point on the unit circle where theta equals pi over 3. So the point on the unit circle where theta equals pi over 3 is at 1/2 and square root of 3 over 2. So that's what I would put down as my solution for number 6 is 1/2 and square root of 3 over 2. Okay. If you wanted to know what coordinates 5 pi over 3. 5 pi over 3. So you're like, oh, number 6 I could do in my sleep all day long, right? What about number 8? Number 8 says, where is 5 pi? No, number 10, sorry. Where is 5 pi over 3? Well, 5 pi over 3 is down here, right? And it is at 1/2 and negative square root of 3 over 2. So that would be your coordinate. Okay. Is this kind of making sense? A little bit? You guys still here?
Yeah, I
Yeah,
got
it makes sense.
Okay, cool. All right. What about number, this is where it gets slightly tricky, but not that tricky. Okay. Number 14 says theta equals negative 4 pi over 3. Negative 4 pi over 3. So I personally think the easiest way to do this is to look and see where is positive 4 pi over 3. Positive 4 pi over 3 is here at 240 degrees, right? But we want the negative of that. And so if positive, you would go this way, right? And then negative, you would actually move around the circle up here to 120 degrees. So the coordinates of negative 4 pi over 3 are at negative 1/2 and square root of 3 over 2. Okay. So number 14, wherever you're at. Number 14, the coordinates would be at negative 1/2 and then square root of 3 over 2. So I personally think that's the easiest way to do it. Look at where the positive theta is and then flip it around. Okay. So then if you go and you look up here, so this is number 14, right? You had to find the coordinates where is theta equal negative 4 pi over 3. And then if you skip over here to number 48, or 28, I can read numbers. If you skip here to 28, it says, evaluate, if possible, the sine, cosine, and tangent of the real number. Okay, so I know what the coordinate is, right? I know that the coordinate of negative 4 pi over 3 is at negative 1/2 and square root of 3 over 2. Right? So then the sine of negative 4 pi over 3, remember the sine equals your y coordinate, so it equals square root of 3 over 2. And then the cosine of negative 4 pi over 3 equals my x coordinate, which is negative 1/2. And the tangent of negative 4 pi over 3 equals y divided by x. So it's 3 over 2 divided by negative 1/2, and these end up canceling out, and you get negative square root of 3. Okay. Now, if you're like me, I always just, like I said, I like to double check it because that's just what I like to do. I like to see that the math works in Desmos. This might not be you. You might be happy just looking at the unit circle and seeing that. But I like to see it. So I need to make sure I'm in radians, which I am, right? I want to find out what the sign of negative 4 pi divided by 3 is. So that is positive positive 0.8666, which I said was the square root of 3 over 2. So let's see what is the square root of 3 divided by 2. Hey, it worked, right? So then if I want to find the cosine, the cosine is negative 1/2, which is what we found over here, right? And then the tangent is negative 1.732, which we said the tangent is the negative square root of 3, which also matches up. How cool is that? It's awesome, right? I like it when it all works out like that. I'm like, yay. Greta says it's, yeah, that's a good word. She said it's actually satisfying that it all works out. It's like, oh, sweet, it works. The math works, right? So I want to note something on here. You'll see a couple spots, well, every spot it says evaluate, if possible, the sine, cosine, and tangent. Okay. Why would it not be possible to evaluate one of them? Let's go back to this unit circle. So the sine and the cosine, you are always able to evaluate. Okay. But what if you wanted to take the tangent of 90 degrees? The tangent of 90 degrees of the tangent of pi over 2. Well, the tangent, if you remember, is y over x. So the tangent will be 1 over 0. And are we allowed to divide by 0? No, right? Can't divide by 0. So the tangent of 90 degrees of the tangent of pi over 2 doesn't exist. So that's not possible to find the tangent of that. So that's why it says if possible. It doesn't mean like if it's possibly too hard, you don't have to find it. It just means that in some cases you might end up dividing by 0 and it's not possible. And of course, just to kind of prove it all the way around, right? The tangent of pi divided by 2 is undefined because you're dividing by 0. Okay. Shall we do another one? We only have like 5 minutes left. So let's sneak 2 more in really quickly. Okay. So this is a crazy mess. Let me just print screen, do these little guys right here. Okay. It says, for number 36, it says, evaluate if possible the 6 trigonometric functions of the real number. We're going to do number 36, okay? So the first thing that we have to do is we got to figure out what coordinate negative 7 pi over 4 is at. So where is negative 7 pi over 4? So I am going to head back to my unit circle. And I'm going to see is there a positive 7 pi over 4, which there is here at 315 degrees. So positive 7 pi over 4, we go all the way around this way, right? Which means negative, that we're going to go the opposite, and we're going to end up here at 45 degrees. Okay, so the coordinate that negative 7 pi over 4 is at is actually the same as pi over 4, and those coordinates are negative 2 over 2 and negative 2 over 2. Turns out to be not as exciting as I hoped, but that's all right. So it's at square root of 2 over 2, square root of 2 over 2. So this makes the sign really easy, right? The sine of t or theta is square root of 2 over 2. That's the y. The cosine of t is square root of 2 over 2. What's the tangent of t? It's just 1, right? Because it's x over y. So it's just 1. Okay. Now, what about, dun dun dun, what about the cosecant, which is the reciprocal of the sine? The cosecant just basically means that we're going to flip the fraction, right? And we get 2 over the square root of 2. Okay, so this, math teachers around the world gasp in dismay, right? Because we can't actually, we don't leave radicals, the square root of 2, we don't leave that in the denominator. So we have to rewrite it, and we do that by multiplying the top and the bottom by the square root of 2. So then what you end up with is 2 times the square root of 2 over 2, or the square root of 2. So this is technically correct, but not written correctly. This is the correct way to write it, right? So we really don't want that. And if you're going to try to check your solutions, you're going to see something like that. All right, so that's the cosecant. Then the secant is also going to be the square root of 2. And the cotangent of t is also going to be 1. Okay? All right, so then these last few, this is kind of what I was talking about right at the end, that we probably would run out of time, which we did, is what if you wanted to do something like find the cosine of 7 pi? So you have to actually think about what that means. That means that to go around the unit circle one time is 2 pi, right? So you've actually gone around the circle one time, which is 2 pi, then another time, which would be 4 pi, then another time, which would be 6 pi, and then you have pi more places to go. So you're actually going to land over here at -1, 0 on your unit circle if you go 7 pi. So then the cosine of 7 pi is going to be the x-coordinate, and the x-coordinate is -1. Okay. I know we're out of time here. So if you don't get to those two, or get to that end little part, that's okay. We can talk about that more on Monday. Yeah, I think that's probably good. So thank you guys. You guys are now way more knowledgeable about unit circles and how to use them to find trig functions. And hopefully that's